Here's problem 7.6. A 1.6 kilogram block slides down a plane inclined at 25 degrees with the horizontal at a constant speed of 2 meters per second. At what rate is the frictional force doing work on the block? Alright, so we have a block going down an incline, 25 degrees, and the mass of the block is 1.6 kilograms. And we're looking for the rate of frictional force doing work. So we're looking for power. And to understand power, we're going to have to know the force and the velocity. So let's do a free body diagram on this block as it's going down this incline. There's going to be two components of gravity. There's going to be one component of gravity down the incline, which would be mg sine theta, theta being 25 degrees in this case. And there's going to be a component of gravity into the incline, which would be mg cosine theta. And then we're going to have a normal force perpendicular to the incline. And then there's going to be a force of friction against the motion up the incline in this case. So we're going to divide these forces into a coordinate system, x down the incline, y perpendicular to the incline like this. And while this block is going down, it's moving down the incline with some velocity equal to 2 meters per second. That's not part of our free body diagram, that's just additional information. Okay, so if we look at this free body diagram, we see that the frictional force is opposing the mg sine theta down the incline in the x direction. And we're also told in the problem that it is moving at constant speed. Constant speed means that there is no net acceleration. It's moving at constant speed, no net acceleration in the x direction. So we could set up our equation, summation of all the forces in the x direction, to be mass times zero acceleration, or zero. And that would be equal to mg sine theta minus the frictional force. In other words, the frictional force is equal to mg sine theta. And in this case, that's going to be 1.6 kilograms times 9.8 meters per second squared sine 25 degrees. And this is equal to 6.63 newtons. So that is the frictional force acting on the block. Nice to know. Let's consider now the power situation. The power expressed by this frictional force. We have this frictional force that's going up the incline like this, and we just found its magnitude to be 6.63 newtons. We have this velocity that's going down the incline like this, and the magnitude of that is 2 meters per second. So the angle between these two vectors is 180 degrees. So in our power formula, we have power is equal to the dot product between the force that we wish to find the power expressed with, dotted with the velocity. Power is equal to force dotted with velocity. So this would be the magnitude of the frictional force times the magnitude of the velocity times the cosine of the angle between those two vectors. This is going to be 6.63 newtons times 2 meters per second cosine 180 degrees, because they are in opposite directions. That's the angle between the two vectors. And this is equal to, well, since the cosine of 180 degrees is a -1, this is equal to a negative 13.3 watts, joules per second. So that is the power. The rate of frictional force doing work per time is negative 13.3 joules per second, or negative 13.3 watts, the power of the frictional force.